Good day all. Now we're looking at another example under DC machines. Now this question says a 250 volt shunt wand DC motor. Shunt DC what motor. So these two statement has these two words will define our diagram and how it will look like. Now solution, let us start solving. As usual, you draw the reason for drawing this diagram is for clarity's sake. It will help you understand what you're dealing with. So since we're dealing with a motor, we will be having back EMF and not generated EMF. That's the first. Then here is our armature resistance, our field resistance, and since it is a motor, that means it is converting electrical into mechanical. We'll be having our arrow in this direction, no longer in this other direction, and supplying to this and to this. So while in generator it was the other way around, the motor supplying current to the two other parts, but this time around it is now the terminal, voltage terminal, supplying current to these other two parts. So take note of that. You have here to be your IF, here to be your IL, here to be your IA. Okay, I think that's all. Now, okay, so they said a 250 volts. So we are expecting that our what? Our terminal voltage will be what? 250. Has a field winding resistance of what? 50. So here is what? 50 ohms. And armature resistance of 0.2 ohms. If the current taken from the supply is what? 25 ampere. This is the supply. The current taken from the supply, if the current taken from the supply is 250, 25, so calculate the back EMF. So in this case, our formula has changed. Now we'll be having our formula to be VT, which is the total voltage, is equal to this first part. The V, since there's no resistance around here, our VT value is also the value at this point. So we can say the V at this point is responsible for whatever that is happening and whatever is happening here. So if I were to consider this other part, we have that VT is equal to your IF rho F, or for this other part, there will be, you have your back EMF, and you also have your armature resistance voltage drop. So we want to get our what? EB. So we can't get this, since we can't use this formula. Can't use this formula since we don't know what IA is. We don't know what IA is. It wasn't given in the question. The only current that was given was this guy. So, and in this case, our current, using our KCL, we had that our IL, which is the one entering this node, is going to be equal to our IF and plus our IA. So if there's a way we can get our IF, we can make our IA set our formula to get IA, since we already know what our IL is. Yes, but there's a way we can get our IF. We are given RF. So using this portion of the formula, we have that and we're trying to get IF. So we can say that IF from that formula is equal to VT all over RF. Your VT was given to be 250 volts, and your field resistance was 50 ohms. When they divide, you're left with what? 5. You're left with 5 ampere. So we have gotten our field current. So we can simply just put that here and make this get out of formula. So we have that from here, let us call this I. So from I we have that IA is equal to this going over, we have that IL minus IF, and we know this to be what? 25, and the other guy to be 5. Hence our armature current to be 20 ampere. So since we have gotten our armature current, we can now use this formula to get our EB. Now use the formula to get our EB. So let us write down the parameters that we have gotten. We know that our IF is what? 5, and this to be what? 20 ampere. So okay, so now you can either use this or this, whatever you want to choose, but they are all the same thing. So whatever you choose to, which of the formula you choose to use to get this. So me, I'll be choosing this portion. This portion of the formula. So we are trying to make EB sort of formula. We have that EB is equal to our VT and this guy crossing over. Our VT is 250 volts and our IA is 20 ampere and our armature resistance is 0.2. Now with our calculator we can get our value. We have that 250 minus 20, 0.2. This will give us 246 volts. So this is our back EMF value. Subscribe to the channel if this was helpful. Thank you and God bless you.